Hey, welcome to Jason versus the Moon. Today, what are we going to be doing? Well, what we're going to be doing is actually, we're going to come back to what I was talking about. My first set of videos about is NASA taking real images, or are they making fake images look real? And I mentioned in there about me compressing a Saturn image I took down to 2.1. I need to correct myself. It was 2.7 kilobytes, not 2.1 kilobytes. The photo that I was trying to find that was 14 kilobytes of Saturn on NASA.gov's website is not accessible. I've tried and tried and tried. Just anything, and it just spins. It doesn't do anything. So I can't go and look that up currently. So what we're going to do is take those images and kind of compare them. And this will be from the very beginning. The image you see here is at 540 kilobytes. Let's go check that with properties, and 504 KB. Okay. So what we'll do is start here, and you're going to see I'll adjust levels. It's already pre-done, but let's go. And there you go, you can see some stuff going on. You see some weird stuff going on. We can zoom in a little bit, you know. Yeah, I mean, nothing like what we see on NASA.gov images. So let's go ahead and jump to 10.6 kilobytes compression. That's my photo, just compressed down from 504 to 10.6. And let's go ahead and do some stuff. Okay, here we go. Let's look. We got a little bit of stuff going on, the boxes and colored boxes and all of that. What I want you to take a look at, though, is the blackness of space. And I'm going to show you the levels off, levels on. Okay, and just check out all of the gray and things going on in the darkness. Just keep that in mind for right here in the future when we show the Saturn images from NASA.gov. Here we go with 10.6 and a little bit different levels, and I'll just go ahead and let it play. In fact, I'll let it play without stopping, probably. 3.1 kilobytes compression. And I have to stop. And the reason is now we're getting some serious, what I guess is considered JPEG artifacts. You can see a lot of weird stuff around Saturn and things. And the blackness of space, once again, just really crazy. Okay, so we'll just continue. 3.1 kilobytes still. This right here is 2.7 kilobyte compression. That's the lowest I could get it. And we will pause it and go in a little bit. You can see, like, it's just kind of weird now. It's really, really strange, okay? But we are at 2.7. Okay, there's a little bit different view for you. And now we're coming to NASA. Now I'm going to show you this here. Let me check my time. NASA looming, I'll go ahead and click on it so you can see that it is in fact the same image, 3 little stars or whatever, and then here you can see 3 stars, well 4, it doesn't matter, same picture, right? Okay, so let's go back to it, and what I found, at least when I downloaded it, was the size 9.40 kilobytes. So let's see what 9.40 kilobytes looks like. Okay, we got a little bit of stuff going on. Okay, I'm not, you know, well, wait. Let's actually go to this one and let's take levels off. Now, why is everything, why is there this ring on the right side, not ring, but horseshoe, around the right side of Saturn in space? Also, here's a good place to point out. Look at space here and just check it out. You don't see all the gray and black, you just see black. Yeah, you see these little bits of gray, you see that. But let's go back and remember on mine, look at this. Okay? So, now we're on this, very strange, and we'll zoom in a little bit. You can see really, really weird. Not even the same, because, I don't know, it's just not the same as mine. Okay, and then we got this. Let me zoom back out for you. Let me just let it play out. I got a few more. Okay. And now, check this out, the white, right? And then with my white, it's still bringing up grays and blacks. But with theirs, it's just white. A little bit of gray, but everything else that's supposed to be space, no, nothing. Alright, and then the last one, that just doesn't do much of anything. I just kind of lightly tested it. Actually, you can kind of see there's a shadow or something here. I'm not sure what that's supposed to be. It's kind of cast. Yeah, I guess a shadow or something. So, anyway, I don't trust these images whatsoever. Let's check the time. We're doing good. Let's go here, and I'm going to show you a little something. The phone that I took those pictures with was 13 megapixels. It's a phone camera, LG Aristo 3. I attached it to a Celestron Celestron Nexstar 8SE 8-inch telescope. So I was working with a phone camera, and you can see the quality. Let me just refresh your memory. I know we've had a lot go on in a short period of time. Let me zoom back out, and I mean, look, you know, it's fuzzy, but it's there. You can see stuff, the range, you can see like the space and stuff. So it's not horrible from a cell phone camera and a land-based telescope. But let's read a little bit on here. Let's start from the top real quick. On July 19, 2013, an event celebrated the world over. NASA's Cassini spacecraft slipped into Saturn's shadow and turned to image the planet, 7 of its moons, its inner rings, and in the background our home planet Earth. Okay, now that's from the Cassini, right? That's a picture that's supposed to be official, I guess. Here's a little demonstration of what the Cassini is. Huh. Sure would be nice if, you know, they could show us the real thing. I mean, if this is even just the science subsystem or the imaging science subsystem part of it, I mean, they're not showing us the real thing. CGI, computer generated image, or graphics. But let's take a look at this. Check my time one last time. The two cameras were similar in some ways to digital cameras on Earth. The wide-angle camera used lenses, while the narrow-angle camera used mirrors to focus light on a detector called a charge-coupled device that converted light into digital images made of pixels. But while today's cameras on Earth have detectors with dozens of megapixels, Cassini's cameras built in the early 1990s were closer to 1 megapixel. Closer to 1 megapixel. That's okay, just think about that. Think about that. This picture is from a 1 megapixel, almost a 1 megapixel camera. This picture, compressed down to 9.40 kilobytes from unknown, you know, original kilobytes or whatever, gives us this. Look, let's zoom in just a little bit. I mean, it gives us this, a 1 megapixel camera gives us this. Get out of here, you know. Cornell University planetary scientist Peter Thomas, a member of the imaging team who studies Saturn's moons with Cassini's cameras, said the cameras were far more carefully calibrated than Earth cameras and were built to survive more than 10 years in the harsh conditions of outer space. The cameras were built so well, in fact, that they continued capturing mind-blowing images for nearly 20 years after the spacecraft left Earth. 20 years of capturing mind-blowing images, and it's closer to 1 megapixel camera. Cassini's camera provided far more information than consumer-level digital cameras because they were sensitive to all wavelengths of light between the near ultraviolet and near infrared, a range greater than typical visible light cameras. Each camera had a variety of color filters mounted on a wheel that selected the range of wavelength or color for the camera to record with each image. Now that's just some stuff from official, you know, solarsystem.nasa.gov, and you can read the rest. That's going to take too long for me to do that, but you can see there at the top. Pause the video if need be. And you can go read it for yourself, but even, you know, common sense would tell me that even with all of these different types of filters, I don't see how 1 megapixel camera can give us just these mind-blowing images for nearly 20 years. So that just is something to question. Thanks for watching.